In this video, we will be going over snow loads, which is found in ASCE 716, Chapter 7. Now, the best thing that you can do when working with design codes is to just read the chapter cover to cover. And that's going to give you kind of an overview of everything that's going on as far as it pertains to snow and snow loads. However, once you do that, then you'll be able to dive in and look at more specifics of that chapter. So the first thing you want to do when trying to find your snow loads is find your ground snow load, which is abbreviated as PG. So that's your ground snow load. And the first place you're going to look to find that is going to be in figure 7.2-1. And in this figure, it's a map with values of the ground snow loads in different locations. Now, a couple things to point out about this map. In certain locations, there are red areas, and those indicate that the ground snow loads have been tabulated on the next few pages. And then there are also like these bluish, purplish sections. And those indicate, they say CS in them, and that means case study. So it means that's usually for mountainous regions where the elevation changes rapidly, and so they can't fit all the numbers into this little map, and so a case study has been done in that section. So you just need to check with that jurisdiction and they'll be able to give you the snow loads for those areas. So once you pull that value off, the next thing you're going to want to find is your minimum snow load, which is abbreviated PM, which can be found in section 7.3.4. And there are two different equations for your minimum snow load. So the first one is going to be this importance factor times your ground snow load, and that's going to be for PG is less than or equal to 20 PSF. And if PG is greater than 20 PSF, then you're going to use the equation 20 times IS. Now, just as a reminder, IS is your importance factor, and it comes from table 1.5-2, and it's based on your risk category, which you can determine on that same page, which is page 5 of the provisions. Next, you're going to want to find your flat roof snow load. which is abbreviated as PF. And that is going to be found in section 7.3, and more specifically, equation 7.3-1, which says PF equals 0.7 times CE times CT times IS times PG. Now the CE is your exposure factor. And can be determined from table 7.3-1. The CT here is your thermal factor. And can be determined from table 7.3-2. Again, this is your importance factor, and this is your ground snow load, which we've already discussed above. Then you're going to want to find your sloped roof snow load. Which is abbreviated as PS. And that's going to be found in section 7.4. And you're going to use equation 7.4-1, which says that PS equals CS times PF. Now this CS factor is your slope factor. And that can be determined from figure 7.4-1. And again, this is your flat roof snow load, which was determined from up above. So those are your different types of snow loads. Once you do that, you're going to want to find your unbalanced snow load. And this is used in situations where you have some sort of sloped roof, some gable style roof, and you've got snow sitting here, you've got snow sitting here, and then the wind comes and blows in this direction, let's say, and it's going to pick up this snow over here and drop it over here, and it's going to pile up over here on this ridge, just like that. So the wind, again, is going to come pick up this particle of snow here, move it up, 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 and it's all going to get piled on this side of the roof. So unbalanced snow loads are talked about in section 7.6. But I personally like to look at something more visual rather than just read what it's talking about. I like to see what it's actually saying. So you can see a visual of this in figure 7.6-2. And that just helps me better visualize what's going on, and it has everything written out right there. However, one thing to note from the text that it doesn't talk about in the figure, you can't visualize from the figure, is that unbalanced snow loads only apply to roofs with a slope that is greater than 1/2 on 12 and less than 7 on 12. If you're not within this limit, then this unbalanced condition does not apply. Also, another thing to point out, and you can see this on the figure, is that you're going to have different unbalanced conditions for when your W is less than or equal to 20 feet, or if W is greater than 20 feet. And again, that W, as depicted in the figure, is this distance here, from one end all the way to the center of that gable. So this here is going to be W, and this is W. Finally, the last condition we're going to talk about is snowdrift. Now, drift occurs when there's a spot on a roof or there's an attached lower roof where when the wind blows, the snow can pile up here in this area, or if the snow blows in this direction, it'll come like this, and it'll drop and pile up down here in this area. So when the wind's blowing in this direction, this is going to be leeward drift. And when it's blowing in this direction, this is going to be windward drift. Now, you know that it's windward because the wind is going to push the snow into some obstruction where it's piling up. Versus leeward, it's just going to kind of drop it off and pile it up in that section versus pushing that snow up against a surface. So if we had a mirror image of that, and let's say so we've got our gable roof, and then we've got some other roof coming off of that structure. So in this case, this would be our windward. And this would be our leeward. Again, because windward is going to push this snow into the obstruction and cause snow to pile up. Whereas leeward is just going to cause snow to drop into a gap and pile up. Now, drift is talked about in section 7.7, but again, I'm more of a visual person, so I like to use figure 7.7-2, and that visually depicts what's going on as far as drift goes. So let's go ahead and define some of those things in figure 7.7-2. So we've got HB, which is going to be equal to PS over gamma. We have HC, which is going to be the height of your upper roof, minus the height of your lower roof minus HB. Now, one thing to note is that if HC over HB is less than 0.2, then you don't need to apply drift loads. And that's just because your HB in comparison to your HD is so much larger that really adding a little bit of drift isn't going to make that much of a difference on your structure. So then we've got HD, which is determined from figure 7.6-1. Now, you can plug values directly into that figure, or just below it there's an equation. I like to just plug everything into the equation because you get more of an exact number rather than just eyeballing something. And for that equation, your LU is going to be different if you're calculating your windward or your leeward. So LU is going to be the length of your lower roof when you're calculating for windward drift. And it's going to be the length of your upper roof when you're calculating for leeward drift. And also, once you determine HD from the equation or from the figure, you're going to determine your drift height. And that's also going to be different if you're looking at windward or leeward. So for windward, your drift height is going to be 3/4 HD. Again, that's for windward. And HD for leeward. And once you get to this point, you can usually compare these two values, and whichever is greater is going to be the HD that you use for design. Next, we can look at the width of our drift, which in the figure they just define as W. And again, there's going to be a couple different options. So it's going to be 4HD for when HD is less than HC, or it's going to be 4HD squared over HC for when HD is greater than HC. Now, for both of those, your width is never going to be greater than 8HC. And just another thing to point out when we're talking about width, if we've got this roof section here, let's make that a little, and say this roof is just really short. Say you end up calculating your width and you get your width to be 9 feet. but this here is only 5 feet. All that means is you're going to start at 0 here and then just go up to your regular height. So your width can only be as long as your roof is going to be. Your snowdrift can't come out and hang in the air like that. So you're just going to start at 0 and then work your way up. So it's just still going to be that triangle, but it's only going to be 5 feet long rather than the 9 feet that you calculated. And then lastly, as far as drift goes, calculate your value, your surcharge of drift, as HD times gamma. Again, this HD is the HD that you're going to select from up here. Whichever is greater of these two values, you're going to plug in right here for HD. And this gamma is your density of snow, which can be found in equation 7.7-1. And that says that gamma equals 0.13 pg plus 14. And it's important to note that that's never going to be greater than 30 pounds per cubic foot. And that pretty much does it as far as, generally going over how to calculate your snow loads, your unbalanced snow loads, and your drift snow loads. We do have full examples of how to calculate all of this in our written examples, and those are pretty straightforward and easy to follow. Again, you just find those in our written examples. Now, there are always exceptions to the rules and things that kind of get tricky in weird situations. And it's kind of hard to come up with an example for every single one of those random scenarios. So if you do have any questions, head over to our homework help page, and we'll be able to get those weird random questions answered for you. Also, feel free to contact us. By email, taylorstutoringcenter@gmail.com, or you can use the chat function found on this webpage, and that all gets sent to the same place.